Hello and a very warm welcome. Welcome to this special webinar uh, co-hosted by ETAuto and SAE India, that's Society of Automotive Engineers India, in this collaborative initiative of a webinar series on technical topics which are very pertinent in the automotive industry. And it's my pleasure to also inform you, to those who have not attended perhaps any of our earlier webinars, this is the fourth edition in this collaborative effort. And this edition will focus especially on automotive durability and NVH validation. Now, we all know that durability is a key factor for any brand, and the more durable a vehicle is, the more appreciation that the customer has for that particular brand. And when it comes to NVH, who doesn't want a quiet ride, right? Be it in a truck, bus, or even a truck, bus, passenger vehicle also. So therefore, NVH becomes all the more important, and especially in the current times when the electrification megatrend is on the rise, and with the change of the powertrain from internal combustion engine to a battery electric powertrain, the most noticeable change is the noise factor. And therefore, NVH becomes all the more a sensitive topic, a crucial topic, and NVH levels have to be much better in an EV, be it a passenger vehicle or a commercial vehicle, than an equivalent ICE vehicle or internal combustion engine vehicle. So therefore, that NVH becomes very critical, and durability, as I mentioned, with these new developments, be it electric vehicle or the hydrogen, and now on the passenger vehicle side, there is the ethanol norms of the blending of 20% ethanol starting April 1, 2025. These things are also kind of influencing the durability factor, and therefore engineers are busier than ever before to find out, to really develop new solutions, push the technology envelope, and enhance the overall durability quotient, as well as NVH in the vehicles made in India and elsewhere also, of course. But now we have with us today, during this webinar, we'll have technical experts from the industry, and I'm not one of them. So it's my pleasure to invite on the virtual stage Mr. Nagasuresh, who is responsible for NVH attribute engineering, product development at commercial vehicle major Ashok Leyland. So without further ado, let me invite Mr. Nagasuresh to deliver the keynote address and share his valuable insights with all of us on this topic. Over to you, Nagasuresh.
Thank you, Sumatra. Now, for the sake of bandwidth, I will just shift to the video mode. So, I am Nagasuresh. I am working as in the NVH attribute engineering team at Ashok Leyland Technical Center. So today I am going to have give you a brief overview on the NVH attribute engineering and critical NVH development aspects that are followed to achieve the desired vehicle comfort and durability targets. So we'll have a basic intro on NVH first, and then I will go into the target setting and the durability aspects of the NVH. So this is for the beginners, so pardon me for this slide if people know things. What is NVH? What does NVH stands for? NVH stands for noise, vibration, and harshness. These are the subjective feelings and the first impressions which are perceived by the customers, maybe it be a driver or a passenger inside the vehicle from the time when the vehicle is switched on. So what is noise? Noise is any unwanted or uncomfortable sound, and it is also subjective in nature. Noise for one can be music to other. Coming to the next term, vibration. Vibration is a motion or a displacement of any component or structure with respect to specific reference position like floor vibration or seat vibration or the tactile vibration which you feel in the vehicle. The third term is a tricky one, which is the harshness, which is a combination of both vibration and auditory sensations, which are perceived due to sudden changes in the abrupt changes which occur during the vehicle travel, like unprecedented coarse road or rough road in touch, which is very much disagreeable to senses. So this is a basic definition which we just wanted to share. So the importance of the NVH, why it is important, and what does it mean to the customer.
Hello?
Hello, am I audible?
Yeah, you
Due to the increase in number of means increase in the refinement levels which are demanded by the customers, so customer wants more and more quiet and comfortable vehicles. So good NVH is needed for safety and good health of documents. So as long exposure to noise and vibrations will have a detrimental effect on the health of the occupants or drivers. So not only the occupants inside the vehicle, the commuters on the road will also be impacted by the noise emissions. So the government has some legislative requirements which are set for the vehicle in terms of noise. So these are some of these include the pass-by noise and also the in-cab noise. So which every OEM has to adhere and meet as per the relevant testing standards set in order to meet the final NVH requirements and certification. So additionally, the design of NVH also helps in reducing the component failures, which is the topic of interest for today's lecture. So component failures and addressing the structural issues in the vehicles, we need a good NVH. And finally, every OEM will have their own brand image. So building a good brand image will also need a good NVH, which can be an USP. And a unique offering which can be offered by the vehicle to have a competitive edge over the other vehicles or other brands. So why we are talking about NVH, how complex it is. So we have many systems which we can see in this slide over here. So many systems which will be some of which are sources, some of which are transfer paths, and some of which are like receivers. So we have to work as an NVH engineer. We have to work to solve the noise and vibration issues of each and every system and subsystem level. Starting from location of the brackets on the frame design, engine and gearbox design, mount isolation targets, and they're all to be validated during a design stage itself. All these will contribute to the noise and vibration in the vehicle, and good NVH target setting both at vehicle level and component level is crucial for NVH development in terms of both comfort and durability. So now we shall have an overview of NVH development process, and it is a generic process which I have shown on the screen. So it starts from benchmarking and target setting, which is the first phase. This is knowing the customer and knowing what the customer needs and knowing the market trends and everything. And it will start from the next phase will be a component level development phase, and followed by proto level testing and development phase, and finally pilot vehicle testing phase and sign off. So in benchmarking, it is crucial to identify the vehicle level targets and cascade the targets to the system and component level and have a proper DVVP, which will be very much crucial in identifying the proper validation procedure and identifying the flaws or some failures at the early stage, because you can work at the early stage with proper DVP and proper targets. So this will help further during the component level development phase, where we have proto component testing and validation of the targets and system level CA correlation. So and also the NVH refinement of the components. And once the components manufacturing and prototyping is mature to a certain extent, and we go for a full vehicle development, and vehicle level also we will have a do a vehicle testing and with CA correlation again, because CA will have some play here. And suggestions and modifications are also important for achieving the targets and also norms. So as an NVH engineer, we not only provide targets, we have to also achieve them with the proper suggestions and solutions, which should be again achievable and manufacturing friendly at optimal cost. So final development will be on pilot vehicle. Once the full fledged production vehicle is available, we have to test on the pilot vehicles and build at the and to see the final deliverables and have a sign off. So major impact, why we are discussing today, major impact of NVH development. It starts from achieving regulatory performance and certification, which is mandatory one, achieving the customer delight by delivering best-in-class comfort, and also achieving a long life of the components with improved durability. This will be these are all the major three impacts which proper NVH development will have. For today's topic of interest, we will be concentrating more on comfort and durability aspects, including the target setting and the challenges what we have. Because these two appear to be good and are required by the customers, but sometimes we face the challenges in target setting for both comfort and durability. There will be like a tug of war situation. So we'll have some examples of this in the coming slides. So as we have seen earlier, in the benchmarking. So the benchmarking will start with the development process of a vehicle for NVH will start with the benchmarking. And benchmarking will have a mix of what is the competition, what are the market trends, and jury evaluations, and what is the positioning, where the new vehicle is going to be positioned, what should be the cost targets, and all those things, and are considered, and also along with the comfort and durability requirements. And we arrive at a target book. This target book will be to a extensive level, starting from the vehicle level to the subcomponent and to the subcomponent level, and it also includes the subjective assessment targets as well. So why this is crucial? Because many of inputs will go into preparing these targets, and this is very key, as we have some charts which will show you next, so which are more crucial for vehicle and component life. So all these are captured here. So when it comes to durability, the major key factor which is to be considered here, I just wanted to have one brief slide on the topic of resonance, because this is one of the key item due to which we have component failures. So what you see here in the screen is physical structure will have many natural frequencies. Any physical structure physics will have any natural frequencies. And when these natural frequencies are excited by the excitation force or sources, and when these two coincide, we'll have an effect called resonance. And at resonance, which occur at excitation frequency of a source like engine or a gearbox, this we could see that there will be a total failure of a system, because at a resonance we cannot control the system. So only damping will help in avoiding total loss during the resonance. So resonance is detrimental, and component life also lead to detrimental to the component life actually, and it will also lead to the noise and vibration issues. So why we have talked about resonances? These are the model alignment chart, which is one of the byproduct of the target book. So this we have x-axis is nothing but a frequency, and on the top we can see the various modes where the components are structural resonances, and those should be aligned properly so that the excitation forces like engine excitation and other gearbox excitations or some you should not get coincide. And these range of excitations from sources that are calculated based on operating parameters and location of various modes of different structures, and where they should be in order to avoid resonance and therefore achieve the comfort to the occupants and durability of the components. So this we have like you can see, we have many components in the vehicle. So for each component, we will be setting the system level and component level targets, starting from a frame, engine, gearbox, the exhaust, propeller shaft, and axles and, steerings. So the methodology what we adopt here is target cascading methodology. So once we have target at vehicle level, it has to be cascaded at system and component level, and from source. So we'll start with the source. So what is the source excitation, and what is the path where the excitation is transferred, and how the receiver is receiving, and sensitivity of the receiver at each of this location. We'll have the targets. So for example, we have engine as a source. So noise and vibration targets for the engine are set, and what is the attenuation level the body should be for the vibration and acoustics, and the transfer function targets. And finally, what are the targets it has to be achieved at the passenger area, like in cabin or this. So once we have targets at the vehicle level, these are to be cascaded till the component level. So challenge here, what we are seeing here is whatever I have told. So we'll take one example here, like we have engine and mounts on which the engine or gearbox is mounted, and we have a body and tactile body or response area, like in cabin, steering wheel, or frame. So one of the well-known, this is one of the known examples where we have the challenges to meet the comfort and durability. So if you see if you consider the targets which are to be set for the mount, so the targets of the stiffness, if you see, those will be uh, need to meet a certain isolation target and also the durability requirement. So if you see isolation target has to be met, it should be a softer mount. And if you see you want to have a durability to be met, may need a harder mount, or stiffness should be high. So here we have a tricky situation, and optimum stiffness needs to be calculated here, and how we have to deliver both with what are all the other improvements which you can make in this target setting, that we can see based on. So in order to achieve the final isolation and durability targets, we can optimize the damping and the material also, and as well as the volume and show hardness of this. And same way, at the input level also, the combustion optimization, balancing, improving the balancing of the engine, and sometimes we need to go for a different material, so with optimizations, and identifying natural frequencies and optimizing the natural frequencies, and avoiding resonance within the components at the engine source will help though to reduce the input to the mounts itself. So once the input excitations, everything can be reduced, so the mount delivery, mount stiffness optimization will also have can be optimized. And finally, at times we may have to work on the receiver point as well, like structural natural frequencies of the receiver components, such as steering wheel, and sometimes we may have to use mass dampers and damping at the floor kind of thing. So in a nutshell, if you see, so to optimize the stiffness of the mounts and the path alone, if you see, we can reduce the vibration, we can reduce the excitation as well with the proper target set for the source, and also the targets set for the receiver end as well, so that finally we can achieve both the isolation and durability requirements. This is one of the case which we can see. Similarly, if you we have many such sources as we can see, like engine noise targets. So some of the major transfer path targets which which are listed here, like engine noise targets, engine block vibration targets, and first bending mode targets. So why we are emphasizing on this target setting is a target setting at each level, like source, path, and the receiver at upfront will help in finally achieving the desired comfort and durability. So one more example here, you can see the propeller shaft. If you can consider, the unbalance of the propeller shaft and will also have a detrimental effect and influence on vibration transfer to the body and structure. So unbalance level of the shaft should be very low, and unbalanced RPM should also be higher enough so that it will be away from the operating range. Similarly, different sources are listed here, and once the sources level targets are achieved, and path, if you can see, so mount isolation targets will ensure the transfer of less transfer of engine excitations, and passive side vibration targets of the mounts coming from the mount to the frame will also improve the reduce of transfer of vibrations from the engine to the frame. And structural sensitivity of this of the mount at the attachment of the frame brackets at the attachment of the mount will also has to be set properly. And the body structure sensitivity and suspension targets, these are the some of the targets which have to be set for the path. And at receiver stage, finally, at times when we cannot ship this some of the targets, we will go for mass damper kind of thing. But at least some targets, basic hygiene has to be set, like steering wheel model targets and floor vibration levels, what should be the vibration level, and model targets for the cabin, and noise targets, and acoustic insulation, what is attenuation which we require for the acoustic package also to be set. And also sometimes we could see the torsional excitations, reducing the torsional excitations will also help and improve the comfort and also improve the life of the gearbox and the engine and driveline components. So like this, good target setting and proper DVP validation upfront, and the correlation of CA and physical test data will help to achieve to identify the problems in design and perform countermeasures at the earlier stage itself. So some of the similar targets we now have shown it at each component level. So engine to the steering wheel. So these are all some basic targets which we can set. So this is a overview which we just wanted to have a session here. So sorry, I had limited time given, so I have to hold it here. So any questions you can.
Okay, thank you, Nagasuresh. Thank you very much, Nagasuresh. I understand that you will have to log off a little earlier because of the approaching cyclone in Tamil Nadu, Cyclone Bengal. We hope there is very minimal damage, if at all, because of the cyclone. But this is an annual affair, so a natural occurrence which we cannot avoid. But quickly, Nagasuresh, if you can just take one or two questions. There's a question which is asked, which is, what are the property files that we require for CAE model in order to analyze in-cabin noise?
Property files I could not get, but in-cab noise can be analyzed like if they have to analyze in-cab noise, they may need to have the transfer functions. So I just wanted to have some clarity on this, which property files means we can directly measure at in-cab noise. So only thing, they have to predict the noise. If they have to predict the noise, they need a transfer function data, acoustic transfer function data, and source level noise data. Suppose they want to predict the engine noise, in-cab noise. So there are many sources like engine, gearbox, all those things. So we'll be measuring the data, or they can, if they have their unit excitation of this engine and various components, and the transfer function data of these components to the in-cab. So which is the receiver point. So they can construct a model and go for a prediction. So it is like transfer path analysis we call. So transfer path analysis, like interior noise transfer path analysis.
Okay. And another question is how to reduce engine idling vibration. Would be from through mounts, I would assume.
Yes. One is through mounts and setting the proper frequencies, and ideal vibrations are more greatly and mounts are actually mainly are for the ideal and cold ideal conditions only. So these are the things, and thing is designing the right mount and model means which will absorb the properly decouple the 6 DOF and the roll modes of the engine will deliver a good attenuation, and also during idle, if you want to say that vibration coming to the floor or some other component, so component natural frequency should not also be not sensitive to the excitation or the ideal frequency. Suppose you have a steering wheel and you have excitation of 30 hertz coming from the engine, and the steering wheel natural frequency should not be at 30 hertz. So engine can so these are the things which can be taken there, but surely it is through mounts and this natural
And
frequency.
I'm sure with material science, there's a new kind of composition of materials, which is also helping to develop
Yes.
new technology mounts which will absorb these noise and vibration better.
Yes.
Yeah.
Yes.
Last question before we let you go. Can you suggest better CAE tool for NVH? What are the CAE tools that you would suggest?
Because I am into experimental testing, physical,
Okay.
so I may not be the right person to suggest because I have not used major tools.
Okay. Because you
So
are more into attribute engineering, right?
yes, we are into attribute engineering, and I am into physical testing.
Okay, great. Okay. But anyway, Nag Suresh, thank you very much. I understand that the weather is changing there
Sorry,
in
I had to rush
Chennai.
up. Sorry for that. Otherwise, I just
No,
wanted to
not at
stop.
all. Absolutely. And please go home safe, and wishing no, you all no, well and be safe, and no, have a good safe journey home. Yeah. Thank you.
Okay, thank you.
Thank you. It was a very interesting presentation. Who would have thought that at least, I mean, the non-engineers and outsiders from the automotive industry, but purely on NVH and attribute engineering, it can be such a complex subject. So isn't it, Krishnan? Let me now welcome Mr. Krishnan Sadagopan, chair of SAE India's Automotive Forum, who's a very passionate engineer himself, an industry veteran. So, Krishnan, this is, I mean, one sub-segment of the automotive engineering, but still such a huge canvas, quite complex, and it's getting increasingly so, isn't it?
Yes, yes. It is being mandated also. That is also there. It is regulated. That is
right.
It's very interesting subject.
Yeah. So, and Krishnan, great to have you again in this fourth edition of this collaborative effort between SAE India and ETAuto. Your thoughts on this particular edition, which focuses on NVH and durability.
Yes, actually, this topic is NVH and durability, more related to clutch actually. There was a prediction tool earlier, clutch, bearings, based on the tonal noise, they will predict the life of the component. That is why this topic was given NVH and durability. As an Auto Forum coordinator, I wanted to make our audience to understand first the basic levels of noise and basic durability. That's why we are here, Gopi Krishnan Trivikraman also, ex-fatigue expert and from passenger car. And we have invited Naga Suresh for basic NVH. That is one. Number two, noise can be modulated, not can be suppressed. For example, whistling noise, brake squeal noise, like that many noises are coming, and doing a CAE will tell you only frequency, resonance frequency. CAE will always say, you move away from resonance frequency. We used to say, when we develop a bracket, frequency should be 500 Hertz. It is very difficult to design a bracket 500 Hertz. That was the target. We used to get 300 Hertz, 250 Hertz, depending on that. When we used to arrest all axis, that way it is. Similar to that, this transfer path analysis, first it is better to measure, then we will simulate in the CAE, because we should know the baseline where we are. For example, one simple example I can tell you. If you generate 20 G of noise or 20 decibel in the engine, after engine mount on the chassis, it should be 2 decibel. That is what the mount will be designed. Normally, people used to say, soften the mount and stiffen the roof rail. Otherwise, if you are not stiffening the roof rail, you will get air cleaner booming noise behind the cabin. And soften the mount will reduce idling noise. Some question was there. So, okay. And one more thing, this noise evaluation is a very critical and tricky, very tricky. For example, every day in the portico, when you just start a car, you could see the reflective noise around the portico, a big noise is there. That too, if it is a diesel car, diesel combustion noise added to that. Till this common rail was getting evolved, right now there is no mechanical injection pumps. When I made the first common rail engine in India, when you put on the vehicle, suddenly many noises started coming. But the theory says common rail should reduce noise. Then we realized the mechanical pump noise was 20 decibel. And once I suppressed by common rail, other noises started coming. Say power steering noise, gear noise. And then I had a nice engagement with Ricardo that how to modulate other noises based on transfer path analysis and base noise measurement. Even simple thing, when we work on so much on clearances, tomorrow, if the extreme components slightly touches the chassis, if the clearance is only 5 mm, and in one of the variations, if it touches the chassis, you will face the full vibration. Extreme component may be alternator. Every chance that alternator to chassis clearance may be 5 mm, and that is not enough. So normally for NVH purpose, we used to check dynamic vibrations in the SAE. So today prediction tools are there, which should ease NVH, but not much work had been done by ourselves in India. But we have experts are already proven designs are there. Like I told you, dampening items are there. But the thing is, again, dampening component durability is not easy. For example, I can put a rubber damper, but the rubber will become stiff after 80,000 kilometers, then the noise will start coming. What we are aiming. And if you take an oil pan, there will be a drumming noise. So oil pan, even though bigger oil pans, after pouring the oil, it is connected. But it is not fully connected. There is a chance that when you do a SAE, you will observe that how these thickness, 1.6 mm thickness or something, oil pan will bend. And that drumming noise will come. Over and above, even in vehicle design, opposite air will flow. Depending on the speed of the vehicle, how the air is passing through the vehicle, different type of noise will be heard. And that's why in one of the analysis, they say, if truck is getting driven, if the windows are opened, there will be a problem for drivers right here because of airflow and the noise. So that is very difficult. So the noise is detrimental to human being. Noise cannot be fully solved. It can be only modulated. We used to generate an aspirational target. Why not the sound from a silencer gives a music so that public will enjoy when cars are going. So that much, because with 7 holes, we are making a big enlightening sound from a flute. The noise is like that only. But however, there are specific tools are there, like 1 meter noise measurement. We used to do noise apportionment measurement on all the 4 sides of engine in the anechoic chamber. At that time, we can find out what is the source for noise, source of the noise. So easily you can find out source of the noise. From there, we can drill down how to work. In a powertrain, if you take gears, longer addendum gears, that is more than 2 contact ratio, is a must for noise reduction. The earlier designed gears will have contact ratio 1.6. Second, if your backlash is very tight, around 30 to 70 micron, it will give a type of hissing noise. If the black glass is slightly more, it will give ting noise. But however, if black glass is more by theoretical, actual practical, because of the center distance tolerance and your total TIR tolerance, automatically the backlash will get adjusted between ting noise and hissing noise. And any leakages, for example, intake system, exhaust, first thing leakages. So whenever a vehicle comes for NVH evaluation, first ensure that there is no leakage. Leakage will type of this sound is there. So it is first thing is we should see leakage. Second, we should see no component is crisscrossing or touching each other, which will give the bell sound. So we should avoid whistle sound, we should avoid bell sound, then we can evaluate properly. And this study is never ending. For example, if 80 decibel noise you are used to hear, if you go to 74 decibel, then again after 5 years you wanted to change the noise. Change is important. Can we make every vehicle which is plying on the road equivalent to a library room, which is 48 decibel, which is a bedroom, 30 decibel? Can we make that? So that should be aspiration, and each component should, for example, nowadays, if you use more plastic application, and one more thing, surfaces should not be plain. It should have, say, undulations, modulation, or cut in that. Then noise won't reflect.
The noise absorption.
It should absorb. It should not reflect. If plain surfaces will reflect. So like that, noise, you can do a doctorate. But anyhow, I had to give chance to next speaker. So I thought, let me just.
And before we come to Gopinath, one question: when you are talking about the experience of developing the CRDI engine and how, even though there are no mechanical injectors, but still the noises noises have come up because of those noises were actually earlier masked by the NA engine. Similar thing is also happening now, isn't it? Because now it's even more, because from ICE you're moving to practically a noiseless powertrain of EV. So it becomes all the more challenging for engineers.
No, definitely. So they are saying that diesel combustion noise everybody is able to hear now. Now how to remove combustion noise, we have limitations, pilot injection and all. But still that is there. All the more SI engine combustion is very smooth, and noises are, even combustion noise is low. That is challenging only. Right. Sir, only thing if you want, I can tell you, sir. All problem starts when you start the engine. If you switch off, no problem will be there. It will be silent. That's the only answer I can give.
Yes.
Even vibration, noise, harshness, all with switch on the key.
The
one more interesting I can share with you.
Yes.
Whenever we talk noise, whoever are working as an engineer, we will be around the vehicle. We say noise is coming here, noise is coming there and all. But when I was working with one British person, he is not saying that. I asked why. Because he says, you are seeing noise from external. I am seeing from driver's seat. You will go and sit in the driver's seat. You will close it everywhere. Then he will hear the noise. He says driver's comfort is important. At the time, some Lancer car was there. It is from, I think, Mitsubishi Lancer.
Mitsubishi.
The window thickness is 10 mm. So that driver is comfortable when he is going in 120 kmph. And at the time, 120, 130 only road.
Right? Yes.
I was saying, so there are many designs are there. Even when you go at 120 kmph, that huge noise will come if windows are not sealed with rubber properly.
Yes, then comes another aspect of sealing and all.
So NVH inside out, and any European comes and sit on our car, he will say suspension is not okay. Yeah. Actually, our road is not okay because one suspension for many roads. So it's a big doctorate. Let me give chance to my friend Gopi Krishnan Trivikraman, who is expert in durability as well as fatigue. I thought that since the topic is that, let us have a combination. Thank you, Gopi, accepted in a very short time. Yeah. You can, now Sumant, you can take.
Yes, thank you, Krishnan. Always great to have you. And please stay logged in so that we can maybe address some of the questions if there are any from the attendees. And at the same time, I'd like to also thank and welcome. And before welcoming, I would like to thank Mr. Gopikrishnan Trivikraman, who is the founder managing director of InKTech Solution. Just for the benefit of everyone, he's an industry veteran who has had a fairly long stint at auto major Mahindra & Mahindra also, and he is just the right person to have as a subject matter expert on a webinar on automotive durability and NVH validation. So without further ado, let me invite Mr. Gopikrishnan on stage, and the stage is yours.
Thank you, Mr. Krishnan, and thank you, Mrs. Sumantra, for the introduction you have given. Well, yeah, it's a privilege to be invited here in this August forum. I can see 100+ participants. I hope I would do justice to this time given to me. I think some 20 minutes for me. But it was a really interesting background set by Krishnan by telling the rich experience stories and good facts, technical facts. Earlier, we had listened to Mr. Naga telling quite a good amount of technical facts, technical information. So I would rather use my time to interact with the participants who are, I understand, come from a wide variety. Some students are there, aspiring engineers are there, junior engineers, and even I can see some seniors in the lot. But I would like to focus my talk to the junior folks who are interested to know more about these aspects of automotive engineering. So yeah, automobile, right? In that perspective, I'm not going to focus on one particular topic, clutch or something, because as Mr. Krishnan told, I'm talking on behalf of the entire automotive as a product. But of course, you can correlate to each part because it's an aggregate of some 4,000+ parts. The conventional IC engine driven automotive. Now with the electric vehicle coming in, as Mr. Sumantra has described how the evolution is happening in the automotive sphere, lot of components are going out. Like the IC engine, the biggest chunk is going out and replaced by a fewer set of electric motor, battery, inverter, drive line, all these things. Yet it acts as the powertrain. But the overall number of components are less. But as a design engineer, you make every single part correct. Then the aggregate of that may be a sub-assembly that will work fine, and aggregate of several subsystems, chassis, body, interior, powertrain, heating, ventilation, and air conditioning, electrical, electronics, all these 6-7 subsystems together make the product called automobile fantastic. So let's target our discussion on the product level. At the same time, imagine a part level. Now, automobile, yes, as you all know, is in one word we can say that it's a, or a one line answer is that it's a carriage to transport people from position A to B. It's shifting, right? Of course, that produces or that has to happen with speed. Otherwise, it could have been the good old bicycle, right? Automobile, it is self-driven. So it could be an IC engine or an electric vehicle or a solar-powered vehicle. The battery power driven by solar or wind power, whatever. All the renewable energy could be source for driving the engine or the prime mover. So feeding the battery. The battery drives the electric motor and the rest of the driveline. So in the times to come, as Mr. Sumantan told in the initial introduction, that lot of flex fuel vehicles are coming, hybrid energy vehicles, all the unconventional energy. So we can simply say the alternative fuel era. So the auto is driven by many alternative fuel, let's assume. Then the mobility that is moving from point A to point B. Now that needs speed, right? As we just told, and then it causes sound also. As Mr. Krishnan gave very interesting stories, right? Switch off the engine, then all the problems are solved the same way. But still, some of us would like to prefer switch off the engine and still drive the vehicle downhill. Of course, it is a hazard. Never do that way, but we do. Sometimes we end up doing that way, right? Even then, noise comes in. As Mr. Krishnan told us, it's the noise which is felt inside the vehicle. That is for the consumer to feel, not the noise from outside, not necessarily. Then you have not only from the engine, which is the prime source of noise, but also tire noise, wind noise, whatnot. The road, the surface itself creates a lot of noise. So the automobile is not just supposed to run on a smooth highway or a city road. It will transverse through rough roads. It will go through hilly roads. It will go through even off-road applications sometimes, right? We end up abusing the vehicle. It's meant to be used, but we end up abusing the vehicle to pull a load from a paddy field or an agricultural land or a construction site. So even though the vehicles are designed for all these purposes, like passenger vehicle, or off-road vehicles, agricultural vehicles, and within passenger vehicles, there's all the commercial and the personal vehicles. Personal vehicles again split into two-wheeler, three-wheeler, four-wheeler, or the multi-axle vehicles. All these things constitute the automobile. Now, at this point, before I get into the facts of the product, a little bit market gyan, if you are interested. Automobile industry, why the hype? It's everybody, every boy, and these days even most girls want to join automotive industry. Many companies are now headed by the world's longest number one company, General Motors, right? For 75 years, JM was world number one. Is now headed by a lady CEO. Maybe first of its kind in the worldwide thing. And then in India also, Mahindra is a company, last mile connectivity, or headed by a lady. So Kinetic is headed by a lady. So more and more women power come into the automotive field. So it's an open area for all. And then naturally the hype is much high. Everybody wants to join the automotive field. Now in India, that's 7% of the GDP, as you all know. As we are at a $4 trillion economy, it's coming to around $300 million US dollar, or say 25,000 crores. It's a huge industry, worldwide also. 10 million vehicles produced. That's 1 crore vehicles sold every year. Volkswagen, Toyota at the topmost. And in India, we have Maruti Suzuki leading the passenger vehicle segment, two-wheeler Hero, so Tata, Ashok Leyland, all these things constitute around 30 lakh vehicles, or 3 crore vehicles annually put up by India. India is now the fourth largest producer of automobile, as you all know, and bigger than this, there's a third largest market. The sales or Indians buy vehicles in this number, which is the third largest in the world. When we produce, it is not only for our internal consumption, but also for the export. So just like we all know, India is a large producer of mobile phones, shipping. Apple also to the entire world. Same way, Indian cars, Indian trucks, Indian two-wheelers exported everywhere. Now, when we design automotive, we have to think about these things in mind, and that's why I'm talking about the market, because durability is a big thing. I'm coming to the topic that way, that the vehicle, whether you design it in India, make in India, export it to abroad, it has to survive the durability aspects of that road, or that field, so to say. Same thing in India. So it has to operate on a diverse terrain. For example, we sell a car in Delhi. Okay, and then that car not necessarily runs only within the good roads of Delhi. It goes to Haryana, Punjab, or even even the upper hills in Uttarakhand. So it has to endure all. It is supposed to be run all over the world, right? Maybe barring Antarctica, it will go everywhere, right? So it is supposed to be durable all through. Now, these are the few things we said about. Then it produces it has speed, and it produces speed sound. Maybe we can limit the sound, that's all, but it will still be there. And then another thing as affiliated to automobile is the aspirational part, the beauty of it, the shape. Okay, maybe the fourth S is shape. And then comes the pride associated with that. Okay, so it's owning an automobile when we have only penetration of two cars for 1,000 people. Sorry, 20 cars. Maybe that is 2% penetration in the Indian market. It's an aspirational product, right? So we don't want it, and we buy a good price for that. Given the per capita income of India, a cost of an automobile is pretty high. So it's a priced ownership. So it has to be durable. For all these reasons, it's an aspirational product, priced high, and it's a matter of pride. So it has to endure a lot of time. So these are the aspects which come to the add to the durability of the vehicle. And durability is not only the long life. It has all the initial quality survey here. It deteriorates under the sun, under rain, under mud, under dirt. All these things. The paint should not go. The part should not wear out. All these things are part of the durability. And the third is the safety. We design parts for a high safety. It is again a regulation matter, like we talked about the NVH regulationary aspect. Durability also come under the regulation in many way. And one particular thing is the safety. It has to endure minor crash or major crash. So it's designed for NCAP ratings, all these things. So even a small dent, as you take a reverse, it hits your own garage corner, that can dent the bumper, right? And then you lose on the insurance, all these things. So durability is an aspect, not just lifelong about the life, or an endurance for a long time, but it is also against deformation, deflection, everything. So all these things are the technical aspects of durability. I will come to that in a while. So the importance of durability lies there. And now maybe before I go further on the product and the market, maybe in the interest of audience attention, I would like to show something. Give me a second. I'm off. My screen is in.
Yes, screen is in, yes.
Yeah, good. All right. So these are the various test labs, as you see, for durability testing, right? So engine testing we talked about earlier. These guys, for those who are new to the industry, these are some videos I want to show to get you to the mood of the automotive industry, where you do the design development. So do all the virtual designing on the computer using CAD, and then you do the validation in the test labs, and before that you do all the virtual validation on your computer using simulation. And these are the final verification on the car once the prototype is built. So this is the cycle, and it goes to the proving ground at the last, where it should correlate with the field data. Now, what is correlation? Take a look at this video. So this is how we are going to use our vehicle, right? Like it or not, this will happen in some point of the vehicle's life. And those severe data, you take it through the most rough conditions and extract the signals from the field at various points: tire, wheel, spindle, steering knuckle, axle, chassis, body, all these, hundreds and hundreds of points, vital points are there from where the data is extracted. And as Mr. Naga told earlier, that data goes for NVH analysis, crash analysis, durability analysis. And now this on the screen, what you see now is the typical durability axis of the axle, okay, or the leaf suspension spring, leaf spring, as you see here. So these are the real life testing and the multi-body modeling of the same on the computer screen. So after 100 or 1000 different verifications, it goes to the final production stage. All right, so if I can share my couple of slides also, that will give you a lasting impression. So excuse me, is it seen, the PowerPoint slide now, or will I have to share afresh?
I think it's still in that
Yeah.
earlier video.
I see the video thing. Okay, now I'll have to share this afresh. Probably now it's is it coming up?
Yes, and you may like to go full screen on this.
Oh yeah, sure. All right, there you go. So yeah, so the cycles I'll just take you through the design cycles from concept development, preliminary design, validation, and finally to the sign-off. At the product sign-off, that goes for manufacturing, and then it comes to the consumer. We all drive the vehicle, and then but the company, the original equipment manufacturer, that is the two-wheeler or three-wheeler, or for whoever sold it to the dealer and to you, they continue with the improvement, okay, from based on the inputs we give, the users give, or from the service engineers, all this. So that's the cycle of product development. See, and then in the initial stage, as you see here, it's all the shape factor, right? We do hundreds of design, and then we do the engineering of that, of one finalized design from several iterations, 931 model, all these things we follow. We funnel down, and one best design, we go to the details where the size is determined. And this is where the durability factor comes. Okay, so it starts from the size selection. Just now, 5-10 minutes back, Mr. Krishnan told the Lancer Mitsubishi glass is 10 millimeter thick, right? And that is not just durable, it insulates the sound from outside for the in-cab, for reduced in-cabin noise. So now that size selection is not just for the quality, but also the durability of the product or each part. And then that leads to the final geometry with all the fit, form, functionality, the fitness, the right fit comes, and then that's how the geometric dimensioning and tolerancing, GD and TS, you would have heard the word, comes into play.
Now, sorry, Vipi, sorry to interrupt. I don't know if you're changing a slide. It's not reflecting at my end for some reason, in case you are.
Oops. So then without the presentation mode, shall I now, if I go to the next one, are you seeing this new one without the car picture?
Oh, no.
No. Okay. That means I'll come out and change slide every time. Okay. Sorry for all these technical glitches.
No
Without losing further. See, look at some of the pictures, the lab testing in still. We have seen the proving ground, vehicles being driven on all tracks, for durability through the saline water, normal water, dirty water, everything, through the potholes, bumpy ride, large, heavy speed breakers, mild ones, potholes, wedges, all the kinds of road irregularity we capture in the proving ground, and that's where we run the vehicle for durability to gather data, and that data goes to the lab. We have seen the video where the data from the field goes to the lab, and then that goes to the math. So we call it the math to lab to FLM, field to lab to math, FLM correlation of field. This is the field, lab, and the mathematical model on the computer screen. So durability, as I told you, is one major factor behind all these design targets. Now I'm in that slide. I hope you can see this new slide in the process of designing, right?
Yes.
Yeah. Then see, these are the design targets. Strength, invariably everything. Even if you design a chair, it has to be strong. It has to be rigid. Okay. You design a roof for not a car. It has to be rigid. Or you design a mudguard for an auto for a two-wheeler. It has to be rigid. And then comes the performance, where it functions. That's the fit form, and then followed by the function. It has to be smooth, all the kinematics without friction, smooth, no inertia, and all the acoustics, the NVH we talked about, and it gives all the full comfort and the desired speed. And that's the sum of it. Durability, as you define, it's resistance to fatigue, or in short, it is the measure of endurance. It's earlier I told it's life as well as quality or even instant behavior. But when the longest to measure is the life. So if it endures say 5 million cycles, or say 5 lakh kilometers, that's durable. Or if a part gives life more than the product, okay, then that's durability. So this is the way we monitor all these parameters. Let's stick to one thing, this endurance in the chart below. The monitoring parameter is still the deflection, the same thing what we measure for the one-time test. We are all familiar with static tests even in college lab. Some of your students here, you are familiar with the static test in a college lab. You find the deflection of an iron rod or something. The same deflection we measure even in the case of endurance. But it has to be much lesser, because the tolerance band will be much lesser in a dynamic situation, because one time it can stretch more, but several times is the fatigue life will be dependent on the dynamic characteristics. So it cannot deflect more than say 70% of the endurance limit, whereas something which goes beyond the yield and goes into the plastic stage, also we can say it's a one-time pass, but never ever beyond the endurance limit, which will be lesser than say maybe 70% of the yield strength, not endurance, I mean. All right, so you may calculate stress, and if it fails, if stress overpowers the product, rupture. That's the result. Crack or fatigue, fatigue failures, we say. Sometimes it gets crushed also. Thin body parts go into a crack mode. Cast ones go into a complete rupture, destroyal, and so that causes the instability. When we find that one tire is punctured, we immediately feel, right? So same way, if one leaf spring of one of the four wheels is broken, then that affects that leaf spring. As one leaf is enough to destabilize that leaf spring, and that broken leaf spring is enough to destabilize the vehicle as a whole. So that's the effect of it, and it's a heavy cost. We told automobile is high priced, and do you want to change your car again and again just because it is failing? No, right? So then it has to, that's why companies give warranty. It has to endure for long. So warranty is the minimum assurance a manufacturer gives, so that the buyer, the consumer is happy to buy that. It's assured for 5 lakh kilometers, or 5 years of warranty. But the vehicles we designed, as design engineers, we design it for the double or 3 times the warranty, right? Because that's what the consumer would use. Of course, there are recent regulations coming up where the vehicles should be scrapped within certain years. But with even that 10 to 15 years for a normal passenger vehicle, means it could be 4 times the warranty. So you target is to design it forever. So you do all the CAD data, with the right size and geometry we mentioned. It's possibly a summary of what we discussed so far. We do all the virtual simulation on the part and then do all the stress analysis, predict fatigue life, also do all the frequency analysis. Sometimes even bad frequencies can affect durability. So some of the videos we saw in the first part of the presentation where resonance, the term told by Mr. Naga, that can cause undesired failure. It can take the deflection so high that the stresses take you beyond the yield and it will fail. So it's very important to do all the frequency response model analysis and then finally release the CAD data for production. And we continue to do all the design simulation with stress and mass reduced. One of the very big imperative for the electric vehicle, it's the new generation coming to that electric vehicle where it's light motoring, because the battery itself is taking a lot of weight. So let's reduce the weight of the vehicle other than the battery or the body in white, chassis, exterior, interior, everything. So mass should be reduced. At the same time, deflection should not be poor. So that's where we use all the softwares in CAEs, computer-aided engineering softwares, to do the design optimization, where the mass is reduced, but displacement is not, that is the deflection, I mean, is not reduced to cross undue fatigue failure. All right, so that brings to the end of my slides. If time permits, my last minute I'll do to motivate the young generation in front of me to come into this process of engineering. So it's a very exciting to take the vehicle from the concept stage, from the sketches to the product, and do the continuous improvement, product after product, do changes, model year changes, or maybe 5 years down the lane, a mid-cycle enhancement, or re-engineer the vehicle altogether. So these are all the terms we will come across: re-engineering, value engineering, but it all begins with the new product development, which is typically this cycle of concept development, design development, design verification, validation, and detailing before going into the manufacturing. So that's where I would stop on this talk on durability.
Gopi,
on this,
Gopi, your eighth slide is not coming. Last slide. Before
Oops,
thank you. No, before thank you.
Yeah.
Now it's coming. No, now it's coming.
Okay. That is what I was.
That is what you are talking. That slide was not.
Oh,
now
yeah.
It's coming.
All right. Okay.
Now it came.
So
here only you are motivating me.
Yeah, thank you. I appreciate. Yeah, this. Yeah, we are all as seniors. We do all the multiple role we live through in our career. But yes, even I can tell to motivate my youngsters in front that I started as a test engineer, and then that is the validation. I'm proud that design validation was my stepping stone, and then got into the designing field, then got into the analysis, and that brought me to the matured as a product design engineer. So this I hope would motivate the young aspiring engineers too.
I think you had a couple of more slides after this.
No, not. I will stop here. I think I'm already beyond my time of 30 minutes,
okay,
right?
That's fine. Absolutely.
Yeah. So,
no, indeed.
Thank you, Gopi. In a short time, you accepted, and it's wonderful.
Thank you very much, and a very comprehensive picture you have drawn for all of us. I am not an engineer; I'm a journalist. But events like this makes me sometimes think. I wish I was an engineer in the automotive industry. But I am also not regretting my role, because it gives me an opportunity to engage in such close discussions with industry professionals like you, Krishnan, and really. So though I may not have a degree, but I have equivalent of that in terms of the knowledge and the information that I gather. So thank you very much for that. And thanks to Krishnan also. Really, it's wonderful. It's so interesting to know that indeed with these in these disruptive times, the landscape, automotive industry, automotive engineering landscape is getting only more interesting, exciting, challenging. So, and challenges, as we all know, is something which engineers especially really cherish. So I'm sure all the attendees, 100 plus of them here, really find it very interesting. So let me dip into the Q&A box and see the questions that we can address. What methods can be adopted to reduce the harshness issue in vehicles? Please advise in brief. Krishnan, you want to take that?
I can take. See,
you can also switch on the camera if you like.
That's a very good question. It is very difficult to even assess the harshness unless because it is a micro vibration. Normally, people used to define harshness with a human hand. When you do like this continuously, you will get some irritation. You're able to see my hand, no? It will be continuously, it is a irritation. That is harshness. So I told you already, first you clean up the vehicle with no, means no leakages of intake and exhaust, means the airflow path. So if the paths are not leaking, otherwise it will give harshness for you. If there is a leaking, it will give variable sound continuously. So it will be disturbing for you when you are driving if you keep the windows open. Nowadays, if it is AC, so that is not there. But again, when you change the gear, sudden change, it will give harshness. So you could able to feel while change the gear. If you run automatic transmission, then harshness won't be there. It will be smoothly already calibrated. Over and above for co-driver's cabin, when you apply a sudden brake, you will feel harshness. You are feeling, no? You will feel harshness. So harshness is defined like that. And there is one measurement technique for harshness AVL taught us. I forget right now. But there are some measurement techniques with R&D houses are available.
But what are the ways? What are the ways that can be reduced? That's another question we have.
That is what I told. That first, there should not be any leakage in intake and exhaust.
Oh, leakage. Okay.
Number two, component crisscrossing and component should not touch. See, the harshness is coming suddenly. Both the components are rubbing each other.
Yeah.
So that is there. And third one, when you are driving from driver's seat, you should have very good ergonomics on the accessibility of accelerator, brake, clutch. Otherwise, you will be continuously touching clutch. Then if you are continuously overriding clutch, you will face harshness like that. It's only a discipline. First is design, no overlapping. Second is discipline. But there are many papers on harshness, and they will go to the particular place and they will measure and put it. So these are all getting evolved. It's a good question, actually.
Thank you. Thanks. Gopi, maybe you would like to take this question, which is as follows. A resonator is how much helpful is resonator to reduce noise and vibration in engine room? Up to what level, high, low, medium level, is it helpful?
Well, that was a question directed to the NVH expert, but so I'm not, I would rather pass it on to Krishnan.
If it is smaller vehicle like 2-cylinder, single cylinder, the air intake path, the resonator is. If it is a bigger vehicle, it is getting modulated. The resonator is like the air path which is going and coming back, because there is in the intake manifold, it can't immediately accept. There will be that is called as NVH reflection or air fraction, whichever air is coming back, there will be a sudden surge, which will be taken by the resonator. So the resonator can be tuned. Every vehicle, it is to be tuned depending on the structure and acceptance criteria. The resonator is must for single cylinder, 2-cylinder engines. From 3-cylinder also, we have designed resonators, beyond which it may be required, or depending on the filters, that is airflow path, it will be calculated and it can be attenuated depending on this. So it's a must. And
And
the
there's-
exhaust also resonator was there. That is for dampening the noise.
Damping. Okay. And also, there's a question on how to find the propeller shaft imbalance, he means, in terms of in RPM.
That is whirling speed. That in calculation itself, they will design a propeller shaft for a whirling speed of 9,000 or 10,000 RPM. So their whirling speed calculation, there is a limitation criteria. Right now, as I'm not a propeller shaft expert, I don't know the limitation criteria. However, at the end of the manufacturing, propeller shaft will be balanced for in a machine where it will be running to that RPM, and they will find the imbalance, and they will balance with small weights. So all propeller shaft, whatever you are receiving, is a balanced one. So whirling speed calculation to be done.
And how to avoid structure-borne noise.
So that I already told. Soften the mount, stiffen the roof rail. Then the soften the mount, stiffen the roof rail.
Okay. Soften the mount and stiffen the roof rail. Okay. And there is also question about NVH from the brake side.
Brakes feel noise,
Yeah, brakes.
I have no experience as of now, but you have enough papers to read. Brakes feel noise. I have no experience on it.
Right.
Because drum brake, disc brake, both are there, and I have no experience.
There's one question for passenger cars. We do fleet tests from 2,000 to 45,000. Can you suggest for heavy duty vehicles?
You do. What is the question? Last you repeat.
No, he said that for passenger cars, we do fleet tests from 2,000 to 45,000. Can you suggest for heavy duty vehicles?
1,000 to 45,000 kilometer, or what is?
I assume he's talking about kilometer.
No, it depends on what we normally do for one service interval or two service interval, depending on, and it's a combination. 2 vehicles for one service interval and 2 vehicles for 2 service.
Okay.
In commercial vehicle. That is what the durability test. I think he's asking durability test, how much kilometer on the road.
Right.
Depends on the service interval.
Okay.
Service to service, no problem should come. That's all.
Okay. And currently, I believe the service intervals are also increasing, right? With the
80,000 for commercial vehicle.
80,000.
But there are few attention we will do at 40,000. Every 40,000 we'll attend the vehicle.
Krishnan, and this for information from Gopi also. Very glad to receive some feedback here among the questions. Shakti Visheshwar Natarajan says, thanks for the session. And there is another one which says, it is, please, Seshanandan ji says, please share the recording of the webinar, very useful, thanks. So particularly Krishna, I think it's very encouraging for us to have this this kind of feedback. This is an initiative, a collaborative initiative to really disseminate knowledge. And
this is the 4th one, and we have to go 8 more.
Yeah. It's a year-long exercise. So we have just completed the 4th one. So we'll keep coming with more interesting topics every month. So we'll end the year with a very special one. So which we will announce very soon. Yes, and a couple of questions before we wrap up. Krishan, there's a question of what is the feasibility of electrification in commercial vehicles?
Feasibility?
Yes.
Feasibility, 2-wheeler, 3-wheeler, more promising. However,
he's saying especially in commercial vehicles, how much is the feasibility?
Commercial vehicle, terminal tractors, like whatever is moving very less kilometers near port, whatever is running less than 70 kilometers, 100 kilometers. We have designed battery where batteries fast charging. Fast charging in commercial vehicle is 1 megawatt charger is required for 15 minutes charging. So that is the main reason. But however, it depends on government push also. Already commercial vehicle means in the buses you started electric vehicles because which is by FAME 1, FAME 2, FAME 3, and government is encouraging electric buses. Tomorrow, if trolley buses comes, it will be like electric train, no? So it is for people movement, it is more promising. And for three-wheeler commercial transport, it is more promising. And for bigger vehicle, terminal tractors, mainly which is operating in the less than 100 kilometer. However, if you want to transport a 16-ton vehicle, you require 3 ton of battery. So today, many research is going on battery, motor, and a software-defined vehicle. If all the three are matured, maybe in a span of 10 years, I think we could see something. Every company is working on center of excellence of battery management, motor, as well as software-defined vehicle.
So it's great. And yes, there's one more question. Is our current engineering capabilities in India depending more on isolators, dampers, rather than designing for NVH? Gopinath, you want to take that?
Well, again, a typical NVH question. I would pass on to the expert.
Yes,
I will
yes,
answer.
thank you. Yep.
Sir, it is 50-50, sir. Over the period, we are working on NVH in India from 81 decibel to 78, 78 to 73. If you ask me, we require R&D house help like AVL or Ricardo or FEV. And we can do NVH components developed in India. Today, dampening components are already available. Even is already manufacturing process is established. But, vehicle to vehicle, it will vary. It is better to work collaboratively and import the technology and indigenize it. That is what I will say. Because it is very difficult for rubber bonding on a plate and to dampen it. So we have to learn. Even mount design, we are still learning. It's not easy for durability of the component. So that is it. Sir, capability is evolving. I won't say it is available. It is evolving in pockets. But if you go to ARI, they have anechoic chamber, 1 meter measurement they will do. Measurement system and testing system is available. Many B&K equipments are there in India. So you can measure where are you. In order for solution, you require collaboration. It is not ready-made available. New technologies are evolved. That's what I was talking to someone. When you are in London, in suburban stations nearby, when you walk on the road, you will hear only tire noise. The vehicle is already dampened. So you have to learn a lot from them. So I don't think so such capabilities exist. Thank you.
Indeed, no, that's where we are. I mean, India has already proven beyond doubt its inherent strength of frugal engineering. But at the same time, as the industry progresses and the automotive landscape evolves, new technologies emerge, collaboration is becoming also the name of the game. No one organization, irrespective of however big or experience it may be, has all the capabilities. So collaboration is increasingly the name of the game, and which is where I think now the organizations, independent organizations, or engineering service providers like Gopinath's firm would also play a very key role. Parting remarks before we close this 4th edition of our collaborative
actually, the overwhelming response by attendance, minimum 100 people every time attending. I'm very much thankful to you, and I hope the knowledge transmission will serve the purpose of the Society of Automotive Engineering Auto Forum. Auto Forum is along with ETAuto. We have just started this for knowledge dissemination so that it will develop together a better world.
Please do log in again. Keep an eye on ETAuto. We will soon announce the next edition of this collaborative effort of a webinar series. do keep a watch on SAE India's social media channels also. And as Krishnan said, this whole idea is to kind of disseminate more information, share knowledge, engage in discussions, and that's how this ecosystem will evolve, which is very, as we all keep hearing from industry stakeholders, that India needs to develop a robust ecosystem for all the new technologies also, because otherwise we'll end up importing or having, depending on organization technologies which may not be available in India. So a robust ecosystem is very critical to be developed, and such that is what the objective of this initiative is also, to kind of develop that ecosystem, much needed ecosystem in India, of which all of you play a critical part. Senior engineers, junior engineers, aspiring engineers, engineering students, the CTOs of tomorrow. So thank you very much once again for your participation. Wishing you all the best. And Krishnan, grateful to you again. Thank you very much.